So hello, today we are basically going to solve this question regarding calculus. It is a definite integral question in which we are basically being provided the upper and the lower limits. In this case, the lower limit is basically 0 and the upper limit is basically infinity. We need to calculate the value of this expression. So first of all, if we need to find the value of this expression, we need to do some certain amount of proofs regarding some theories which we are using in this question. So the things which we are actually proving, we will basically going to do them with a green marker, and the question solving part of this question will going to be done with a black marker. So in order to start approaching towards the solution of this question, we first need to prove that the integration from the integration from the lower limit 1 to the upper limit of infinity of natural log of x divided by fx with respect to the derivative of the independent variable x is equal to negative of integral from 0 to 1 to natural log of x divided by x square f of 1 by x dx. We need to first prove this theorem because this theorem will going to be used in solving this question. So we shall be starting our approach in this. So first, if we need to prove that the left hand side given to us is equal to the right hand side, we will going to take a variable u and let us suppose that it is equal to 1 divided by x. Okay, so now when we will basically going to differentiate both sides with respect to a non-certain variable, then we will going to have du here, and we will basically going to have negative of 1 divided by x square dx. Why? Because we all know that x n derivative is n(x(n) minus 1 dx, and in this case n is equal to minus 1, and so by putting here, it is simple that x minus 1 derivative is minus 1 multiplied with x to the power of minus 1 to minus 1 means minus 2 dx, which we can also write as minus of 1 divided by x square dx. Alright, so now what we can do is, now we can write dx in terms of u. Now dx can be written as negative of x square du, and since u is equals to 1 by x, we can also say that x is equals to 1 by u. So we can basically write that dx is equals to negative of, as x is equals to 1 by u, so it will going to be 1 divided by u square of du. Alright, now as it is a definite integral, we also need to check our lower limit and our upper limit respectively. So now what we will basically going to do is that since we are basically having x as our first independent variable, and the initial inequality in this definite integral question is being set with respect to x, and we need to change it to u. So what we can do is, we know that when x is equal to 1, u will be equal to 1 divided by 1, and when x is equal to infinity, u will be equal to 1 divided by infinity, and 1 divided by 1 is equals to 1, and 1 divided by infinity is equals to 0. Alright, so we are basically here right now. So up to here the things must be clear in your mind. 1 second please, let me adjust my camera. Alright, okay. So now our initial integral was from 1 to infinity of natural log of x divided by f of x dx. We can now write as, in terms of u, we need to have infinity as 0, 1 as 1. Now x is equals to 1 by u, so natural log of 1 by u is negative of natural log of u divided by f of, now x is equals to 1 by u, and dx is equals to negative of 1 by u square du. Now, and we also know that when we need to interchange our limits, we need to put a negative sign, or we need to extract one negative sign. So what we can do is, we can extract one negative sign, due to which the upper and the lower limit will basically going to get interchanged. 0 will going to come to the bottom, 1 will going to go to the top. Now we also know that in definite integral, variable is always independent, so we can now write u again x, because it doesn't matter. We all know that definite integral only calculates the area, and the variable which we are initiating it is only a Cartesian coordinate. Okay, so if we are using u or x, it doesn't make a difference. So we can write x again in place of u, irrespective of the connection in between them. So we can now write x again, so it will be natural log of x. It is a property of definite integral that the variable which we are using in them is independent. So we can write u as any variable. So we are using it again x in order to make things clarified. So here natural log of x negative is there, so it is f into 1 by x, negative of 1 by x square dx. We are basically having three negative signs, so the overall summation will always, or the overall combination of three negative signs will going to be negative. So it will going to be outwards. We are basically having 0, 1, natural log of x divided by x square f of 1 by x dx. So in this way we have proved that our initial integral is equals to this form, which we have proved. Now through this we are basically going to move ahead. Now we are basically having this question. Now we can basically split it as integration from 0 to 1 of natural log of x divided by 1 plus x to the power of 2 plus x to the power of 4 dx, plus integration from 1 to infinity natural log of x divided by 1 plus x square plus x4 dx. Alright, now since we know that we will not going to do anything with it, we will going to write it just the way it was there initially. So 1 plus x square plus x to the power of 4 dx. Now we know from this theorem that integration from 1 to infinity of natural log x divided by a function of x with respect to a variable of derivative x is equals to negative of integration from 0 to 1 of natural log of x divided by x square f to 1 by x dx. So we can basically write this because it is a pattern like this to this form. So it can be written as minus integration from 0 to 1 natural log of x divided by x square. We just need to put 1 by x in place of x here. So it will be 1 plus 1 by x2 plus 1 by x4 dx. Now we have the same lower limit and the same upper limit, so we can now connect them. If we are having the same denominator, by the way, it will going to be 0 to 1 natural log of x divided by 1 plus x to the power of 2 x to the power of 4 dx. Negative integration from 0 to 1. Now we will basically going to multiply x square in denominator as well as numerator to make the denominator in our second definite integral similar to the denominator which we are having in our first definite integral. So it will going to be x square natural log of x divided by, now multiplying x to the power of 2 in the denominator will basically going to make it x to the power of 4, which when will multiply to all these three terms will going to be x to the power of 4 plus x to the power of 2 plus 1. So now we can write it as integration from 0 to 1 of 1 minus x square divided by 1 plus x to the power of 2 plus x to the power of 4 natural log of x dx. Okay, now what we can do is we can multiply 1 minus x square again. Why? Because when we will basically going to multiply 1 minus x square again in the both the numerator as well as in the denominator, now this whole thing will going to turn to 1 minus x to the power of 6. Okay, now you must be thinking that how it will basically going to use as an advantage to this question. It will going to be discussed further when we will basically going to expand the denominator in geometric progression infinite series, and then we will basically going to take this integration as a limit of a sum. Then we will basically going to have integration of 0 to 1. It will be 1 minus x square to the power of 2 divided by 1 minus x to the power of 6 natural log of x dx. Okay, Now one thing I need to tell to you, now let us suppose that we are basically having a summation s, okay, which is of the type of p to the power of 0 plus p to the power of 1 plus p to the power of 2 plus p to the power of 3 up to infinity. Okay, let us suppose that it was of the type like this. Okay, then what we can do is we can have this thing again, we can take p1 out. This thing will again going to become p to the power of 0 plus p to the power of 1 plus p to the power of 2 up to infinity. So it can be written as equals to 1 plus p into s. So s of 1 minus p is equals to 1. So s is equals to 1 divided by 1 minus p, and s is also equals to 1 plus p square up to infinity. So it is a identity which we will basically going to use to expand the denominator of this definite integral, and then we can solve it easily, because now then everything that will going to be in our integrand will going to be on the numerator only. There will going to be no denominator. That will going to make things easy. But yeah, then summation will basically going to take place again. Means when we will going to integrate, then we need to sum them up, but we can do it. I mean, it is still better than solving a integration having a denominator which is fuzzy like this. It has been given to us. So now let us expand this thing. One second. Yeah. Well, now what we can do is we can now write this integration with the help of this concept as integration from 0 to 1. We can write 1 minus x 6 to the power of minus 1 as summation of x to the power of 6 n, and starting from where? 0, ending where? Infinity. Alright, multiplied with 1 minus x square to the power of 2 natural log of x dx. This whole thing is not in the summation. Summation is only this one. Okay, now what we can do is we can take the summation out. Okay, because n is an independent variable with respect to x, so anything which is independent we can take that out of the integrand. So we can have summation of n is equals to 0 to infinity and integration of 0 to 1 x to the power of 6n into 1 minus x square to the power of 2 natural log of x dx. Now we need to solve this thing, okay, in order to get towards our answer. Now my whiteboard is complete to the end. Now I need to start from the first. So let us drop this thing. Now let us write this thing at the top. Now solving this thing is like solving this one which we have approached towards. It is like from n is equals to 0 up to infinity of integration from 0 to 1 of x to the power of 6n into 1 minus x square to the power of 2 into natural log of x dx. Okay, we need to solve this thing right now. Okay, so now this marker is also getting less intense, so now we can use a good marker. I think this is a good one. Now what we are going to do, we will basically going to expand this one. So now what we will going to have is like summation from n is equals to 0 to infinity, integration from 0 to 1 x to the power of 6n. We can expand this thing and it will going to be 1 plus x to the power of 4 minus 2x square into natural log of x dx. It is simply a plus b to the whole square identity which I have used to expand 1 minus x square to the power of 2, nothing binomial. Okay, now open the bracket and multiply individually. It will be like this. It will be x to the power of 6n plus x to the power of 6n plus 4 minus 2 to the power 2 into x to the power of 6n plus 2 whole thing into natural log of x dx, right? Then we can have integration n is equal to 0 up to infinity, integration from 0 to 1 x to the power of 6n natural log of x. Okay, this is the first thing that we need to do right now. This is the first thing which we need to evaluate. Then integration summation from n is equals to 0 to infinity, integration from 0 to 1 x 6n plus 4 natural log of x dx, then minus 2 times of summation from n is equals to 0 to infinity of integration from 0 to 1 x to the power of 6n plus 2 natural log of x dx. Now this thing we need to solve for. Okay, now as you can see in all these three brackets, something common, which is what? It is means all these three are of the type of summation of n is equals to 0 to infinity of integration from 0 to 1 x to the power of m natural log of x dx, right? Oh, sorry. Here will also going to be a dx. We need to find a general solution to this integral, and for this thing to be done, we will again going to use a theorem, a direct value of this type of situation being given to us. So now we need to take our green pens on, and now we need to proceed with the theorem, what it says for the solution of this thing. We need to prove that summation from 0 to infinity of integration from 0 to 1 of x to the power of m into natural log of x dx is minus 1 divided by m plus 1 whole square. Means it is looking such easy, but it is not. Means it is not that easy to prove this thing. So now let us straightforwardly move towards the proof. See, the solution which I am telling to you is easily understandable. Okay, means a 12th grader student of India can easily understand the solution of this question. It is lengthy, okay, in point of view, but it is understandable, and through this question you can learn many new things about calculus, means how to solve problems associated like this, how to use such theorems. Okay, so now let us suppose that natural log of x is equals to u. Okay, if natural log of x is equals to u, then what will x be equals to? X will be equal to e to the power of u. Okay, then dx will be equal to e to the power of u du. All right, now since our original definite integration is having its lower limit from 0 to 1, and this lower limit being and upper limit being established to this definite integral are in terms of x, now we need to make it in terms of u. Since the summation thing will not going to change because n is an independent variable, it has nothing to do with variable substitution here which we are using. Okay, it is only for x, not for n, so this thing will not going to change, only this thing will going to change. So we need to change the lower and the upper limit for u. Okay, now we know that when x is equals to 1, u needs to be equals to natural log of 1. Okay, so u will be equal to natural log of 1, which is 0, and when x is equals to 0, then u will be equal to natural log of 0, which is approaching to minus infinity. How? We know from the graph of natural logarithm that when y is equals to natural log of x, it is like something this. Okay, or you can simply say natural log of mod x, because the domain of x does not allow the involvement of negative numbers. Okay, in negative, natural logarithm and base logarithm fails. So through this substitution and through these lower and upper limit variations, we can now write this thing as integration from 0 is now negative infinity, 1 is now 0, x is now e to the power of u, which is multiplied with m, so it is e to the power of mu. Natural log of x is u, dx is e to the power of u du. All right. Oh sorry, there's no sigma. Okay, we just need to prove this thing. Sorry man, sorry. We need to prove this thing. Extremely sorry man. We need to prove that the integration from 0 to 1 of x to the power of m natural log of x dx is equals to negative 1 divided by m plus 1 whole square. I'm extremely sorry, there's no involvement of sigma sign. We are proving only this. We are not concerned with the sigma sign which I've used. I'm sorry, I've just done that thing through mistake. Now we just need to prove this thing equals to this. We have done some substitutions, like natural log of x, we have put it to u, and then we have proceeded with our lower and upper limit value changing, means as natural log of x is equals to u, and now our whole definite integral will basically going to be in terms of u. We need to make our lower and upper limit of the above original definite integral in terms of u only, so which we have done here. So this thing is now turned into this. Okay, now it seems quite easy to solve. Now it's like negative infinity to 0 e to the power of m plus 1 u d u. Now what I will going to do is I will going to multiply 1 divided by m plus 1 whole square here. What I will basically going to get through it, then I can multiply m plus 1 here with u. Okay, then we are having e m plus 1 u, and the another m plus 1, as it is a constant, I can simply put it under a derivative. So this m plus 1 and m plus 1 can cancel this, and so we can basically rectify. And now we all know that in definite integral things are always variable independent. We can take this thing as t. Okay, and since m plus 1 is nothing but it is just a scalar thing, it will not also going to affect our lower and upper limits. Okay, because this thing will multiplied with minus infinity will still be minus infinity, and when multiplied with 0 it will still be 0. So it will going to be 1 divided by m plus 1 whole square integration from minus infinity to 0. It's like t e to the power of t dt. Now it is extremely easy. We know how to evaluate t into e to the power of dt et. It will simply going to be t integration e to the power of tt dt minus integration dt by dt integration e to the power of t dt. What we are basically using here, integration by parts. So it will going to be t into e to the power of t minus e to the power of t, because it will going to be 1 and then e to the power of t integration e to the power of t again. Okay, alright, plus constant. Okay, but still but as we all know that it is a definite thing, so we are not having any constant here. It will going to be t minus 1 into e to the power of t. Upper limit is 0, lower is minus infinity, so it will going to be 0 minus 1 e to the power of 0 minus of minus infinity minus 1 e to the power of minus infinity. So it will going to be minus 1 into 1 minus of minus infinity into 1 divided by e to the power of infinity, which is infinity. So it will be 0, so it will basically going to be 0, so it will basically going to be minus 1, which means that this whole thing is equals to minus 1, and so the whole summation means, or the whole value of this thing is equals to 1 divided by m plus 1 whole square minus 1 attached to the numerator. So we can say this thing that our solution is negative 1 divided by m plus 1 whole square, which we need to prove. Now using this theorem in all these three brackets, and then we can simply reduce these integrals, then we can sum up them through the summation given, then we are done. Okay, so now let us proceed further. I need to erase because I have proved these things, and you need to go check on these provings. So let me erase these stuffs, please. So now I can write them as 1 second, man. Oh man, sorry. I can write them as integration from n is equal to 0 to infinity. It is simply m plus 1 to the whole square, so I can write it as minus 1 divided by 6n plus 1 whole square plus summation of n is equal to 0 to infinity of minus 1 divided by 6n plus 5 whole square then we are having minus 2, and this thing now can be turned as summation from n is equals to 0 to infinity minus 1 divided by 6n plus 3 whole square. Alright, so now what we can do is, now we can have 3. We can do that, we can take minus out, summation n is equals to 0 to infinity 1 divided by 6n plus 1 whole square plus summation of n is equals to 0 to infinity 1 divided by 6n plus 5 whole square plus summation from n is equals to 0 to infinity 3 divided by 6n plus 3 whole square. Oh sorry, it will be 2. Sorry. Now I can write 2 as 3 minus 1. Okay, and I will going to take this minus component under this bracket. Then what I will going to get is summation from n is equals to 0 to infinity of 3 divided by 6n plus 3 whole square minus of summation from n to 0 to infinity 1 divided by 6n plus 3 whole square. Then write these two summations. Summation from n is equals to 0 to infinity 1 divided by 6n plus 1 whole square plus summation of n is equals to 0 to infinity 1 divided by 6n plus 5 whole square. अब यहाँ पे एक ट्रिक की बात आएगी. 6n plus 1, 6n plus 3, 6n plus 5, all of them are odd, and we also know that any odd number can be represented in the form of either 6n plus 1, 6n plus 3 or 6n plus 5. This thing is known as Euler number theorem or Euler number representation. अपने को पता है कि जितने भी हमारे पास odd numbers होते हैं उनको हम लोग 6n plus 1, 6n plus 3 या 6n plus 5 के फॉर्म में अरेंज कर सकते हैं. तो ये जो टोटल समेशन हम लोगों को यहाँ पे दिख रहा है, ये समेशन और कुछ नहीं बल्कि हमसे यही कहना चाह रहा है कि हमको सारे के सारे ऑड नंबर्स के इन्वर्स स्क्वायर का सम करना है. ठीक है, और अगर हम लोग इसको इवेल्युएट करने का सोचें तो ये आ जाएगा, हम लोग ऐसे 3 बाहर ले लेंगे तो 9 बन जाएगा. इट विल बी 2n plus 1 होल स्क्वायर माइनस इज लाइक समेशन फ्रॉम n इज इक्वल टू 0 टू इन्फिनिटी और 1 डिवाइडेड बाई 2m plus 1. ये सारा ऑड नंबर का समेशन है. ठीक है, और ये भी वही है. सो 1 minus 3 minus 1 of summation of n is equals to 0 to infinity or 1 divided by 2n plus 1 का whole square. This is also the sum of all the square of the odd numbers, and this is also the sum of the inverse square of all the odd numbers available. Just the difference is that here we are having the factor of 3 by 9. Now this thing, we all know that summation of odd numbers can be like summing all the numbers minusing the summation of the even numbers, which is 2n whole square. So it is like minus 2 by 3, and it will be 1 minus 1 by 4 of summation of n is equals to 0 to infinity 1 by n square. And we all know that this is a Riemann-Zeta function of the value 2, which is equals to pi square by 6. This was founded by Euler, we all know that. अब ये summation of n is equals to 0 to infinity 1 by n square, which is also the value at 2 of the Riemann-Zeta function z is equals to pi square by 6. This is also known as Euler summation. How it is derivable, I will basically going to explain this in some other videos or some other upcoming videos, that how it is pi square divided by 6. But for now let us take the value only. So we have arrived at the answer, which is minus 2 by 3 into 3 by 4 into pi square by 6, which is equals to 3 can be cancelled, it will going to be 2, and so minus pi to the power of 2 by 12 is our answer for this question. Thanks for watching this video. If you liked it, then it will be really much appreciable from me. This is the whole complete solution, if you can see it. There are various things which I have rubbed. So I will going to meet you with some other question, interesting question or theorem in next videos. Till then, bye bye.